Hi everyone, and welcome back to part 2 of section 14.2, which uncovers some flaws in the voting methods. So in the last video, we looked at a criteria called the head-to-head criterion, and we had said that voting method, the only voting method that does not have the potential to violate the head-to-head criterion is the pairwise comparison voting method. What we're going to look at now is a criterion called the monotonicity criterion. And one thing I do want to point out is that all the criteria for fair elections is only really relevant when an election is repeated. So as long as you choose the voting method before holding the election, the method is considered fair. But if you have different voting methods that you're employing, you would expect whoever won the first election to win the second one, as long as it's fair. But we know that doesn't always happen. And a lot of these voting methods have flaws that are just inherent. So a repeated election is when the same number of voters choose among the same candidates. Sometimes what will happen is, they'll have a straw vote where they'll have, let's say, 3 candidates, and they narrow it down to 2 after taking that first vote. And then they'll have another vote after the straw vote. And if one candidate gains votes at the expenses of the other candidates, if that candidate was winning, you would expect them to win in the second election, but that does not always happen. Okay, and that's where this criterion, the monotonicity criterion, comes in. So it uncovers a strange flaw in the plurality with elimination voting method that we talked about in 14.1. So let's take a look at an example. The Marketing Committee of Publix Groceries is considering 3 new services to offer: delivery, self-service checkout, and catering. To obtain an initial measure of the intentions of the committee, a straw vote is taken, and the results are given here. So this is like a preliminary election, okay? And we have our preference table there. After several hours of debate and discussion, a second vote is taken. In the second election, the 5 people who previously voted CSD now vote SCD. So C is catering, S is self-checkout, and D is delivery. So now it's the self-checkout, and then for first place, and then the catering for second, and then delivery for third. So this change has the effect of eliminating the CSD column. Okay, so right here, that column is going to go away. So now what happens is those 5 people that originally voted in that order, we're going to add them over to this column. So that's where we get 16 now in favor of self-checkout for first, and catering for second, and delivery for third. Okay, so what we're going to do in letter A is using the plurality with elimination method, which service wins the first election. So remember, plurality is looking for the candidate with the most number of votes, right? They would come in first place, as long as they have a majority of the votes, which is more than 50%. If that does not occur, we will eliminate whoever had the lowest number of votes and then hold another election. Okay, so we'll call this round 1. And in round number 1, it says which service wins the first election. Okay, so the first election is referring to the straw vote here. And if we take a look, we've got the C, which gained 8 plus 5, or 13 first place votes. And D has 9 votes, and S is 11 votes. So we can see that delivery had the lowest number, and we also don't have a majority because in order to have a majority, we would need to have, let's see, 8 and 9 is 17, 17 plus 16 is 33. So 33 people voted. We would need to have half of 33, which is 16.5. So we would need like 17 people at least in order to say that a majority won, and we don't have that. So with plurality with elimination, remember we're going to eliminate the lowest, which would be the delivery, okay? So now we're going to have another election, so we'll call this round number 2. And here we just have C and S left over, okay? So C is still going to be, if we're looking at the first preference table again, it's just 8 plus 5, okay? So remember, D went away, so you can even cross that out, okay? All the D's are no longer there. And if you notice, there's no C's that shifted to the first spot. So it's still 8 plus 5 or 13 votes. But now when we look at S is going to overtake the second place there, and it overtakes the first place there, and then it doesn't move anywhere else. So one way we can do this, instead of adding the votes, we could just take 33 minus 13, which leaves us with 20, but we're getting that from 9 plus 11, right? The 2 places that S shifted into first place. But it should add up to our total, which is 33. So as you can see here, we needed at least 17 to be a majority. We got 20 for self-service. And since that is the type of service that came up the most, first place votes, and also the majority, so more than 50%, we can say that the self-service wins for that voting method. So self-serve. Okay. So now we're going to use the same voting method, but we're going to look at the second election. And you would assume you would still get the same winner. Okay, so let's see what happens. So looking at our second preference table, round 1, we have C is 8 first place votes, D is 9, and S is 16. Okay, so we don't have a majority, we're close. So we're going to cross out the C, and then we're going to do a second round of voting. Okay, and this time, so there's no longer C, so we can cross them out. And here, D is going to move up and S is going to move up. And here, D just moves up. Okay, so D now has 8 plus 9, or 17 votes, and S would be 16. So as we can see here, the delivery wins because it has the highest number of first place votes, and it's also a majority. So delivery. So as you can already see, we did not get the same winner, right? You would assume that you would. So did that violate the monotonicity criterion? You can pause the video and think about, if you need to reflect on what that criterion says and whether the result violated that criterion. And then you can unpause when you're ready. So yes, it did violate that criterion because 5 voters changed their ballots, right? So if you're looking at the first table here, these 5 voters changed their ballots to support self-serve and then catering and then delivery. So they added support to that order, right? But the victory that was not repeated in the second election, right? So self-serve won the first time, but it wasn't repeated in the second one. So yes, that did violate that criterion. So if we were to summarize, as we saw, the plurality with elimination method has the potential to violate that criterion, the monotonicity criterion. You should also note that the Borda count method and pairwise comparison sometimes also have the potential to violate the monotonicity criterion. Okay, so we're going to write that in because that's important. Okay, let's take a look at another flaw, which is the last one that we're going to talk about. It's called the irrelevant alternatives criterion. And it basically states that if a candidate is the winner of an election and in a second election, one or more of the other candidates are removed, the previous winner should still be the winner. Okay. However, we're going to see that that doesn't always happen. Sometimes that kind of action can actually negatively affect the winner. Okay, so let's take a look at an example. So the Valencia Intercultural Student Association is holding an election to select a club president. The choices are Anderson, Bakari, Mendelson, Sanchez, and Tompkins. The election results are shown in the table. Okay, so there's our preference table, and it goes all the way from first place to fifth place. Prior to the announcement of the election results, it's discovered that Mendelson had dropped out of the election. The election officials then decide to eliminate Mendelson's name from the election results. So what we're going to do is use the pairwise comparison method and determine which candidate wins the election if Mendelson's included. Okay, so in other words, we're just going to look at this table based on what we have here. Is who would be the winner if Mendelson's included? Okay, so first of all, I want to add up that top row, which will give you 88. So there were 88 votes that were taken. And we've got 5 candidates. Okay, so we have quite a bit of pairwise comparisons to make. So remember, there is a formula to figure that out. It's just n times n minus 1 over 2. And n is the number of candidates. So here we have 5 candidates. So we're going to do 5 times 4 over 2, which comes out to 10. So we have 10 different pairwise comparisons to make. Okay, so let's just start out with A. Okay, so we're going to have A versus B, and then we're going to have A versus M, A versus S, A versus T, and then I'm done comparing A to the other 4 candidates. So now I'm going to just start with B, and I'm going to do my comparisons with those. So we're going to have B versus M, and then I'm going to have B versus S, and there should be one more, B versus T. And then I'm finished with my comparisons with B and the other candidates. So all that's left are S and T. So I'm going to have S versus T, S versus M, and that's it for S. And then all that's left will be T versus M. That's the only combination we didn't compare. So all we're doing is we're going through, right? And we're figuring out in the first one, A versus B, I'm going to look at my columns, and anywhere A goes first and B is underneath it, we're going to take those number of votes and award it to A. So in other words, if I look at that first column, it goes B, A. So I'm not going to count that, okay? B, A. But here I've got A first and then B underneath it. So we're going to add up the 16 because it goes AB. And then the same for the other column. It goes AB. And the same for none of the other columns. So it's just 16 plus 16. So A gets 32 votes. And then to get B, you can just subtract 88 minus 32, which gives you 56. Okay, and you're going to do that for all of them. So if you would like, pause the video and try filling in the other ones, and I'll write those in right now. Okay, now we're going to go through and figure out who won in each of the pairs. Okay, so whoever got the most points. So here we can see B, A, S, T, M, B. Okay, here we have a tie. S, S, and M. Okay, so let's go through and let's take care of A first. Okay, did A get any points? So it looks like they got one point. Okay, next we're gonna take care of B. So B got 1 point plus another one is 2. Here it was a tie, so remember they get half a point each. That would be 2.5. So B gets 2.5 points. Okay, then we have, let's do M next. So did M win at all? M won here, they got 1 point, 2 points. So 2 points for M. Then we have S is, let's see, 1 point and another point. So that's 3 points. So far S is winning. And then we have T, last but not least. So that's 1. And then remember, this is a half a point because it's a tie. So 1.5. So T gets 1.5 points. So the person that scored the most points was Sanchez. So Sanchez is the winner. Okay. So now remember, they found out that Mendelssohn had dropped out of the race. So we're going to do the same voting method, pairwise comparison. This time we're not including Mendelssohn. Okay, so when you're in the table, you want to cross out anywhere M is, and then remember everything, if it needs to, is going to shift. So keep in mind that these two are going to shift up. Okay, here B is going to shift up into that space. Here, these three are all going to shift up 1. Here, B and A are going to shift up. Here, this whole column shifts up, and the same for this column here. Okay, so there's no longer 5 places, there's 4 places. So what I would like you to do is pause the video now and try doing the pairwise comparison on your own. And keep in mind, you're not going to have 10 comparisons anymore because remember, there's only 4 candidates, right? So 4 times 3 is 12, divided by 2 is 6. So all you need to do is 6 different comparisons. Okay, so please pause the video, do the pairwise comparison, and see who you get for your winner. And then unpause when you're ready. Okay, so here we're going to compare A versus B. Okay, and you can use the information you have up here, right? So anywhere there's an M, you don't have to count it anymore, in other words. So you can even cross out, like, I'm not going to look at that because I don't care. I'm not going to look at this one, right? Because M is no longer there. So anywhere there's an M, I just don't care anymore. So it's just the leftovers, okay? So I'll write these in. You can check your answers. Okay, so let's go through and figure out who won now. So here we have B, S, T, B. Here it was a tie again, and S. So if we go through now, it doesn't look like A won at all, so A got 0 points. B is 2.5. S is 2. And T is 1.5. So as you can see, Bakari is the winner. Okay, which was not the same winner as the first election. So does this result violate the irrelevant alternatives criterion? And the answer is yes. Since Sanchez won the first election and then Bakari wins the second election when Mendelsohn was eliminated, right, that would violate that criterion. Okay, so in summary, pairwise voting method, pairwise comparison, has the potential to violate the irrelevant alternatives criterion. So, keep in mind, it's not always going to happen, but it could. Okay, and that goes along with any of the voting methods. So each voting method we've discussed actually has the potential to violate the irrelevant alternatives criterion. Okay, again, the potential to violate. Okay. Suppose that the plurality method, that was the very first voting method that we used, is used to determine the winner of an election, okay? And we have the results of the election that are given in the table. Does this method satisfy the 4 fairness criteria? So remember, the criteria were called the majority, the head-to-head, monotonicity, the one that we just talked about, and irrelevant, the very last one we talked about, irrelevant alternatives. So what I would like you to do is pause the video, and you may need to go back and review, which is completely fine, each of the criteria, and you're determining if the plurality method violates any of those fairness criteria. Okay, and then once you're ready, you can unpause. So remember, with the plurality, it's very simple. We just take our candidates, which we can see are just A, B, and C, and we count the number of first place votes. So just by looking at that first row, we have A is 14 votes, B is 6, and C is 4. So we can see here that A was the winner, okay? Now, did they win the majority? So that's going to help us with the majority criterion. So we have 24 people here, if you add the first row. So half of 24 is 12, and we would need at least 13 votes to be the majority. And as you can see here, A got 14. So did this method satisfy the majority criteria? And the answer is yes. Okay, and it's because 14 divided by 24 is, let's see what that is actually, is a decimal. It's 58%, so that is a majority. So yes, because we got 58%, so more than half. Okay, let's look at the head-to-head criterion. So this one is, think of it as like pairing them up again, but it's not, I don't want you to confuse head-to-head with pairwise comparison. Pairwise comparison, remember, is a voting method. Head-to-head is a criteria used to determine if there's a flaw in a voting method. So, but it's kind of done the same way. So we're counting first place votes again. A would have 14 and B would have 10. And then A would have, if we compare A and C, A again would have 14. and then C would have 10. And then for B and C, let's see, B would be 14 plus 6 is 20, and C would be 4. So here you can see like A would win here, A would win here, and B would win there, right? So no, it does not violate the head-to-head criterion because A still wins, right? A won more times than B did. So yes, it satisfied the criteria. Okay. Now let's do the monotonicity, the one that we talked about today. So here we're gonna think of this as like doing a pairwise with elimination, plurality with elimination. So we have A was 14, B is 6, C is 4, right? We already know that A has a majority, so we don't even need to do another round of voting. A automatically wins, right? So therefore, this does satisfy the criteria. And then the last one was the irrelevant alternatives criteria. Okay, and for this one, you want to do pairwise comparisons. So we already kind of did that right here. And as you can see, A would win 2 points. B would win 1 point, and C is 0 points. So A won, so it satisfied the last criteria as well. So all 4 fairness criteria are satisfied. So therefore, all 4 okay. So in summary there, we've got our 4 fairness criteria, okay, in case you need a little refresher. And what I'd like you to do is pause the video and you can fill in the table here. You're writing in A if the voting method always satisfies the corresponding fairness criteria, or in N if the voting method may not satisfy the fairness criteria. So again, that means that it potentially could, but it has the possibility of also not satisfying it. Okay, so you can pause the video and then you can unpause it and I will show you the answers here. So as you can see from this table, there's not one voting method that satisfies all of the fairness criteria, right? If you're looking though at voting methods that might be the best to use, that could be more fair based on these fairness criteria, it appears that plurality and pairwise would be the most fair because they have 2 criterion at least where it's always satisfied, as opposed to the board account method where it may never be satisfied, and plurality with elimination, the only criteria it satisfies is the majority criterion. So as you can see, there's a lot of there could be a lot of controversy in different voting methods because they have different flaws and they may not be fair, right? Because they don't pass the fairness criteria. So there was a theorem, it was called Arrow's impossibility theorem, and basically it was named after an economist, Kenneth Arrow, back in the 1950s, and he proved that mathematically there's no voting method that can satisfy all 4 fairness criteria. So it's mathematically impossible for any democratic voting method, right? We live in a democracy, to simultaneously satisfy each of the following fairness criteria. Now, as you can see, each one, except for the board account method, will satisfy a criteria, but none of them will satisfy all four fairness criteria at the same time. So again, it's very important if you're holding an election to determine, like if you're on a committee, the committee needs to determine the voting method that will be used and also be aware of the potential of violating any of those voting methods based on the four criteria. And they are not the only fairness criteria, just like the four voting methods are not the only voting methods. We do have other ones, and I do encourage you to explore those methods and the criteria, because if you think of even the United States government, they use different voting methods than we talked about in the book, in Congress. So it's definitely worthwhile to explore all that. And, so you have some background knowledge on that. But anyway, I hope you all enjoy the rest of your day. The next half of chapter 14 is about apportionment methods, and that will be another video.